What if the angle of incidence is greater than the critical angle? Empty test tube placed in water appears silvery due to TIR. It is the surface which separates the denser and the rarer medium. The light should travel from denser medium to rarer medium. It is not incident along the normal. It has to bend. It has to refract. Hello students, this is SD Sir from the Temple of Excellence. Thought for the day for you all. A good habit in one's life is knowledge, and an evil habit in one's life is ignorance. With this thought for the day, let us continue discussing our chapter, Geometrical Optics. My dear students, in the previous session, we learnt about refraction of light and we understood the two applications of refraction. One, what we call as normal shift, and the other, what is called as lateral shift. Continuing my discussion today, we will understand a beautiful phenomenon called as total internal reflection. Please to take note, this is not refraction, this is reflection. Total internal reflection. ಬಹಳಷ್ಟು ಸರಿ ಪರೀಕ್ಷೆಯಲ್ಲಿ ಇದನ್ನ 1 ಮಾರ್ಕ್ಗೆ, ತಪ್ಪಿದ್ರೆ ಇದನ್ನ 3 ಮಾರ್ಕ್ ಕೇಳ್ತಾರೆ. A very important discussion, a very beautiful phenomenon, what we call as total internal reflection. To begin with, I consider a point source of light, a small source of light, O, which is placed in the denser medium. ಒಂದು ಚಿಕ್ಕ LED bulb consider ಮಾಡೋಣ. We will consider a small LED bulb. So O is the point object which is placed in the denser medium, and WX is the interface. It is a surface, what we call as interface. What is this interface, students? We know it is a surface which will distinguish between rarer medium and denser medium. A surface which will separate the rarer medium and the denser medium. So Wx is the interface surface separating the rarer medium and the denser medium. Nodi? Esto simple agide considerations. So O is the source of light, point source of light. Very important. Again I say the source is placed in the denser medium, and Wx is the interface. It is the surface which separates the denser and the rarer medium. Now, to begin with, a ray of light travels along OA. Gamansi, please to understand this. Initially, a ray of light is traveling along OA. What is OA, students? It is nothing but the normal that is drawn to the surface. So OA is the normal that is drawn to the surface. So a ray of light travels along OA. My question is, can this light bend, deviate, or putting in proper terms, can it get refracted? No. Why? It is traveling along the normal. It is incident on the normal itself. And we understood the failure of Snell's law. Snell's law fails for normal incidents. There is no refraction, no incidence. So, in the first part of my show, the ray of light travels along the normal. Which is the normal here? OA, and is not refracted. It doesn't get refracted. Why? Normal incidence. Now watch here. Come on, kids. A second ray of light is now incident on the interface with an angle I. See, the ray of light is traveling from denser to rarer medium. Very important. The ray of light travels from denser to rarer medium. Now, the ray of light is incident on the interface with an angle I. Will it suffer refraction? Yes. It is not incident along the normal. It has to bend. It has to refract. Angle of refraction is R. Now, one more ray of light is traveling from the denser to rarer medium. Again, angle of incidence is I. Here, the angle of incidence is much greater than the previous case. So, angle of refraction also increases. So please to understand, as the angle of incidence goes on increasing, the angle of refraction also increases. Please to understand, as I is increasing, angle of refraction also increases. So as the angle of incidence increases, the bending of light is also more, which means angle of refraction also increases. Now observe, this is the key for the entire phenomena. Now, for one particular angle of incidence, very, very particular angle of incidence, a definition na almost all papers they have asked. See, for this eye, this is the bending that has happened. This eye, which is more than the previous, bending is even more. Now, for a particular angle of incidence, the refracted ray grazes the interference. The refracted ray, if you observe here, will graze the interface. Graze andre just pass on the interface itself, and that angle of incidence is called by a very particular name, critical angle. Please to understand definition of critical angle. It is that specific angle of incidence where in the denser medium, so that the refracted ray just grazes the surface, passes over the interface itself. And beautifully know here, for this angle of incidence, angle of refraction in the rarer medium is 90 degrees. Therefore, by definition of critical angle, it is the angle of incidence. Please to remember this definition. Angle of incidence in the denser medium. Angle of incidence in the denser medium, for which angle of refraction in the rarer medium is 90 degrees. Critical angle andreno? ಅದೊಂಥರ angle of incidence ಅದು. ಯಾವ ಮೀಡಿಯಂ ಅಲ್ಲಿ? ಡೆನ್ಸರ್ ಮೀಡಿಯಂ ಅಲ್ಲಿ. ಹಾಗಿದ್ದಾಗ angle of refraction ಏನಾಗುತ್ತೆ? 90 degrees ಆಗುತ್ತೆ. ಅದನ್ನೇ ನಾವು critical angle ಅಂತ ಕರಿತೀವಿ. So I can give two possible definitions for critical angle. It is the angle of incidence in the denser medium, for which the refracted ray just grazes the surface of separation, the refracted ray will just pass over the surface, or it is the angle of incidence in the denser medium, for which angle of refraction in the rarer medium is 90 degrees. Now observe, this is beautiful. Now, what more? If the angle of incidence is greater than critical angle, angle of incidence critical angle ge samanagidre, the refracted ray will graze over the surface. What if the angle of incidence is greater than the critical angle? Further bending agbekalva, which means now no more topic of refraction. The ray is reflected back to the same denser medium when I is greater than C. For an angle of incidence greater than critical angle, the incident ray suffers total reflection and hence comes back to the same denser medium. And this phenomenon is beautifully called total internal reflection. So by the definition, when a ray of light travels from denser medium to rarer medium, essential condition, denser medium to rarer medium, for an angle of incidence should be greater than critical angle, then what happens to the ray? It is totally internally reflected back to the same denser medium. This phenomenon is called TIR, total internal reflection. So, for TIR to happen, the angle of incidence in the denser medium should be greater than the critical angle. Then the ray is reflected back to the same incident medium. This is called total internal reflection. Now, there are two conditions for TIR to happen. What is the first condition? Come on, recall. The ray of light should travel from an optically denser medium to an optically rarer medium. The light should travel from denser medium to rarer medium. An angle of incidence in the denser medium should be greater than the critical angle. So these are the two necessary conditions for TIR. Angle of incidence in the denser medium should be greater than critical angle. Ray of light should travel from denser medium to rarer medium. Now, we will establish a relationship between refractive index and critical angle of a medium. Mathematical relationship between critical angle and refractive index. Snell's law. Nenpidya, refractive index denoted by N. Same now. Wx in the interface. Ray of light travels from O to P. N is the normal. Angle of incidence is equal to C, which is the critical angle. And R is 90 degrees. Now, follow carefully. From general law of refraction, understand? This is called the general law of refraction. N1 sin I equals N2 sin R. N1 is the refractive index of the medium from which light travels. N2 refractive index of the medium to which light travels. Here I is C, angle of incidence. R is 90 degrees. In this case, light is traveling from denser medium to rarer medium. Conditions held the TIR though. So N1 is N, N2 is 1, which is refractive index of air. On simplification, we get sin C is 1 by N, or C is sin inverse 1 by N. Please to understand, critical angle is always equal to sin inverse 1 by N. As the refractive index of the medium increases, critical angle decreases. As the value of N goes on increasing, C goes on decreasing. So C equals sin inverse 1 by N. Applications of TIR. Sparkling of diamonds is due to total internal reflection. A diamond sparkles because of TIR. Surface of air bubble inside water appears silvery due to TIR. Air bubble, the surface of that appears silver in nature due to total internal reflection. Empty test tube placed in water appears silvery due to TIR, and this is very important for 1 mark. Optical fibers, generally used for communication, they work on the principle of TIR. So in my today's session, students, we have understood the phenomenon of TIR, meaning of critical angle, factors on which TIR depends, and its applications. Go back to the session, understand it thoroughly. Next week, continue with PRISM. Until then, thank you.